Alright folks, here we're going to do some extra examples from class today. So we'll start out with negative 5z to the second power, and that's all in parentheses there. So a lot of people sometimes they just forget that some of these factors in here have their own exponents. So this is kind of redundant or kind of silly, but that has a 1, that has a exponent of 1 on it. Okay, so what happens is some people just forget to square the negative 5 and they only square the z. And if you're ever in doubt, when in doubt, write it out. So if I wrote this all out, it would be negative 5z times itself, negative 5z. Okay, and of course if we're using the property, we can write it out negative 5 to the second power and z to the second power. Either way, we should arrive at a final result of 25, positive 25, negative 5 squared, so 25z squared. Okay. We talked today about negative exponents. And so how do you get rid of a negative exponent? Because you're never supposed to, ever supposed to, never supposed to, ever supposed to have a negative exponent in your answer. So in this case here, we want to get rid of that negative exponent. Remember, if you take the reciprocal of your base, in this case reciprocal of 3 is 1/3, that changes the sign of your exponent. So now I have 1/3 to the positive 2. If you square 1/3, you have 1/9. Okay. This next one, 2/3 to the negative 2, that's same type of problem, except for in this case we have a fraction. So take the reciprocal of your base and change the exponent to positive. So the reciprocal of 2/3 is 3/2. Once I take my reciprocal, my exponent sign changes, and now I can square this and have 9/4. Okay, next one, we're getting a little more involved here, and we're multiplying two expressions together, and we have two powers of the same base. Okay, so first thing I look at is the coefficients. I'm just multiplying here 3z to the 7th times negative 4z squared. And really this could be in parentheses too. Sometimes that goofs people up and they think, oh, I have to distribute or something. Well, there's nothing really to distribute there, so that could also be viewed as in parentheses. We're just multiplying these two things together. So look first at the coefficients. 3z to the 7th and negative 4z squared. Multiply those coefficients together and you have negative 12. Okay, now we'll look at the variable parts. Z to the 7th times z to the 2nd. What do you get when you multiply z to the 7th times z to the 2nd? Well, that's a product of powers, so we're going to add the two exponents, so that's going to be a total of 9 z's. 7 plus 2 for 9 z's. Negative 12 z to the 9th. Okay, moving on. We have a fraction. So here we have a whole fraction to a power. We have powers inside our numerators and denominators. So let's go ahead and take everything to the third power. And we can take the numerators to the third power and denominator to the third power. So really we have a negative 1 to the third power. Put that in parentheses there. We have a y to the third power. And we have a z to the third power. I'll be thorough and put this y in parentheses as well. Okay, and in the denominator we have a z to the 5th to the third power. So if we have a power to a power now, this is where we have to multiply the exponents. So let's clean this up here. Negative 1 to the third power is still negative 1. Y to the third power. Z to the third. This is what I'm talking about. We have that power to a power going on there. So if you have a power to a power, that's when you have to multiply your exponents. So that's going to be a total of z to the 9th. And if you were wondering or you forgot or something, write it out. Z times z times z. So z cubed times z cubed times z cubed again Okay, how many z's? Those are not 2's, those are z's. How many are there? 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. Denominator, same thing, power to a power. I have how many z's there? Z to the 5th, z to the 5th, z to the 5th is a total of 15 z's. All right, any room for simplifying here? Ah, yes, I do see some z's in the numerator and denominator. Well then, let's reduce some of those. I have extra z's in the denominator, which means all of these 9 z's can cancel out 9 of these 15, leaving how many left? 6. So my final super cleaned up, most simplified answer would be negative y to the 3rd, because remember we really don't write the 1's, negative y to the 3rd all over z to the 6th. Okay. Ooh, next one's fun. We have some negative exponents. So what are we going to do with these negative exponents? Well, go through, and if you have any negative exponents and you have a large fraction like this, I want to move them to the numerator or denominator. So I'm going to go through and just highlight stuff that I need to take care of. Right there, y to the negative 2nd, and also down here, x to the negative 3rd. I need to move those so that they're not negative exponents. That's what I'd like to do. So I'm going to take that y to the negative 2nd, and I'm going to move that in the denominator. Okay? And that's going to change the sign. Once I move it down, it changes from y to the negative 2 to y to the positive 2. And I'm going to take that x to the negative 3rd, and I'm going to move that up to the numerator, and that's going to be x to the positive 3rd. All right, let's rewrite this and have it cleaned up. Negative 15 x to the 4th times x to the 3rd, because I moved that up, and then the y I moved down, so that's going to be in the denominator. So I have 3y times y squared. Okay, anything I can simplify there? Yes, there is. I can take these two together and combine them to make one x term, and I can take these two y's together down here, and I can make them one y term. So the final answer, super duper cleaned up, most simplified, would be negative 15 x to the 7th. Oh, hold on, hold the phone, Bolio, hold the phone, back it up. Let's rewind. 3 and negative 15, those both have a factor of 3. So this is actually just negative 5 up there. So watch this here. I'm just going to erase that little bit there. No big deal. No one ever knew about that. Put a negative in there. We have negative 5 x to the 7th all over y to the 3rd. Super duper, totally simplified, best answer ever. Okay, hopefully that helps a bit. Now we'll pop over to the next page and we'll look at some scientific notation. All right, so we can play around with combining and multiplying scientific notation here. And we're essentially using the properties that we just learned about today in class. So, as you know, hopefully, that when you list a number in scientific notation, this part right here has to be a number between 1 and 10. It can't be equal to 10. Okay? So, if I'm going to multiply those two things, let's see, 2.6 times 8.5 is going to give me 22.10. All right, so I have 22.10 times, and then if I take 10 to the 4th times 10 to the 7th, that's a total of 10 to the 11th. Okay, so I'm combining those. One little thing I have to tweak here is that 22.10, 22.10 is not valid for scientific notation. So I have to adjust that. I have to take this decimal and I have to move it one place to the left. So this becomes 2.210 times. Now if I move that one to the left, that number got smaller. So if I move that one to the left, I need to move this number one to the right. One to the right is going to turn that into a 12. Otherwise, I would be changing the value of the number, and I don't want to do that. 2.210 times 10 to the 12th is the product of 2.6 times 10 to the 4th times 8.5 times 10 to the 7th. There you have it. You can also do these, you can also divide like this as well. So if I take 2.6 divided by 8.5, I get 0.31. Okay, so that's 0.31 times, now if I take 10 to the 4th and I divide that by 10 to the 7th, I have extra 10s in the denominator, which really means that I have negative 10, let's see, a negative exponent on the 10 of 3. So I really have 1,000th, not 1,000, because it's in the denominator. It's 1 over 1,000. That's why it's 10 to the negative 3rd. So that's okay, but the 0.31 is not a good number because in scientific notation, the A must be between, let's fill in the blank up here, A must be greater than or equal to 1 and less than 10. So that's not greater than or equal to 1, so I have to slide the decimal point over 1 to the right here. So that will now be 3.1 times 10 to the, if I move the decimal 1 to the right and make the number bigger, I have to move this exponent to the left and make it smaller. So that's now going to be a negative 4 times 10 to the negative 4. So you can divide and multiply and work with numbers in scientific notation as long as you know some of the properties we learned in class. All right, I hope those examples help out, and that's it.